Hello everyone and welcome. In this lesson we will talk about the distance between 2 points in a plane. And as you can see, I already drawn out the Cartesian coordinate system x and y, and also the 2 points, which are P1 here and then P2 here, and also the distance between them, which will be denoted by d. Now let's write out the coordinates for P1. So x1 will be 1 and y1 will be 2. The coordinates for P2, x2 will be 5 and y2 will be -1. Okay, and now let's draw first the distances between these 2 points along the 2 coordinate axes. So first, along the x-axis we have from here to here. This will be denoted by delta x, delta meaning difference, and here we'll have from here to here. This will be delta y. So delta x can be calculated as x2 minus x1, which is 5 minus 1, which is 4. Delta y will be calculated as y2 minus y1, which is -1 minus 2, and it will be -3. Of course, if we look at this delta y as a distance, it will always be a positive number or 0, but now we can leave it like this, -3. Okay, let's draw a triangle. Okay, so we have here delta x equals 4. We have here delta y equals -3, and then we have here d. And of course this is a right triangle. Okay, maybe you recall the Pythagorean theorem, which says the following. Let's draw this triangle again. So we have here A, B and C. A and B the 2 legs or the shorter sides, and C the hypotenuse. So the Pythagorean theorem says that c squared will always be equal to a squared plus b squared. Okay, so in our case d squared will be equal to delta x squared plus delta y squared. Okay, it also means that d will be equal to the square root of delta x squared plus delta y squared, which is the square root of delta x is 4 squared plus delta y is -3 squared, and then this is the square root of 16 plus 9, which is then the square root of 25, which is 5. So the distance between P1 and P2 is 5 units. Okay, now let's try to reconstruct the function which passes through the 2 points. Let's go to the next page. Here you can see the function, the linear function which passes through P1 and P2. So this is a linear function with one variable, which can be written as f of x equals ax plus b. Maybe you recall that a is the slope also denoted by tangent of alpha. This angle is here, alpha, and the tangent of alpha is given by delta y over delta x, and that will be minus 3 over 4, which is minus 3 over 4. So this means that the function is a decreasing function, so as x is increasing, y is decreasing. So this is what it means, the fact that the tangent is negative, or the slope is negative. Okay, so this part was simple. So f of x now is equal to minus 3 over 4 times x plus b. Now the tricky part is to calculate b. This b is actually here, so between 2 and 3, and b is the intersection of the function, or gf, and the y-axis. So we can also say that f of 0 equals b, but this will not help us much. But we can do something interesting. We can take this triangle and we can take the bigger triangle, this one. So we have here two triangles which are similar. Okay, how can this help us? Well, we can use some ratios here. So we can say that delta y over delta x is equal to this distance here. So from B to the bottom of the triangle, divided by the distance from the y-axis so the distance from the y-axis to P2. So this one. In this case, this is pretty simple because this is actually x2, which is 5. So delta x is 4 and x2 is 5. Okay, now here we know that delta y is minus 3, but in this case we will use the absolute value, which is 3. So the absolute value of delta y is 3 because it's a distance. Okay, so let's write this relationship out. So we have delta y in absolute value over delta x. Here I don't use absolute value because delta x is positive, equals, so delta y over delta x will be this distance here, and this distance is actually the distance from the origin to B, which is B, plus the distance from the x-axis to here, to P2, to the y coordinate of P2, which is the absolute value of y2. Here I use absolute value because y2 is actually negative, it's minus 1. Okay, and this will be divided by x2. So now we have a relationship between these two triangles. Okay, let's continue. So we plug in some numbers. The absolute value of delta y is 3, delta x is 4, so 3 over 4 equals b plus the absolute value of y2 is 1 over x2, which is 5. Then this 5 will go up here, so we have 3 times 5 over 4 equals b plus 1, or in other words 15 over 4 equals b plus 1. This plus 1 goes to the other side with the change sign, so b will equal 15 over 4 minus 1. We amplify by 4 here, and then this is the common denominator is 4, and here we have 15 minus 4, and this will equal 11 over 4, which is exactly 2.75. Okay, so b equals 2.75. Okay, now let's go to the next page and try to write out the function. So f of x equals minus 3 over 4x plus 2.75, or alternatively f of x equals minus 3 over 4x plus 11 over 4. Okay, let's check if P1 and P2 are indeed parts of GF. So P1 has the coordinates 1, 2. So if we plug in 1 into the function, so f of 1, this will equal minus 3 over 4 plus 11 over 4, which equals minus 3 plus 11 over 4, which is 8 over 4, which is 2. So P1 of coordinates 1, 2 is part of the graph, so this is correct. Then let's check P2 with coordinates 5 and minus 1. So we have to plug in 5 into the function, which will give us minus 3 over 4 times 5 plus 11 over 4, and this will be minus 15 plus 11 over 4, which will equal minus 4 over 4, which will be minus 1. So P2 of coordinates 5 and minus 1 is part of GF, which is also true. So our reconstruction of the function is correct. This is the form of our function. This can also be done by using, instead of b, the intersection of the function with ox, which is minus b over a, but I will let you do this. So thank you for your attention. See you next time.